welcome back. My name is Nicholas Nikolic, and you are listening to the Android Book Tutorials. These tutorials are based on the Creative Commons work of Mark Murphy, who kindly releases versions of his book, The Busy Coder's Guide to Android Development, and as such, these videos are released Creative Commons as well. I'll read from the book and go through the points directly. You might be warned that this time that I cover up to Android 4.4, whereas the original subscription book is updated on a quarterly basis and covers from Android 6 and beyond. For completely current versions of Android, please purchase a subscription to Murphy's book at commonsware.com. The project you created in an earlier tutorial was just the default files generated by the Android build tools. You did not write any Java code yourself. In this chapter, we'll examine the basic Java code and the resources that make up an Android activity. The activity. An Android project's SRC directory contains the standard Java-style tree of directories based on the Java package you chose when you created the project. For instance, com.commonsware.android results in src/com/commonsware/android. If you check the checkbox in Eclipse for the new wizard, we're not using Eclipse, to create an activity, or selected the menu in Android Studio, or if you use the command line tools to create your project, you will have in the innermost directory a Java source file representing an activity class. For the stub we created earlier in this book, the sample class looks like this. And that would be located here. And we'll see it's very similar. Dissecting the activity. Let's examine this Java code piece by piece. Package, commonsware, publite, and we see the main window, package cool.nic.is publite. Import Android OS bundle. Import Android app activity. Import Android.view.menu. The package declaration needs to be the same as the one you use when creating the project. And, like any other Java project, you need to import any classes you reference. Most of the Android-specific classes are in the Android package. Remember that not every Java SE class is available in Android programs. And this is going to be even more so true in the future, given the next couple of years, Oracle and Google were fighting over as to how much of Java's standard edition should be included. Finally, Google said we're going to take it all out. So just be aware. So public class publite activity extends activity. Activities are public classes inheriting from the android.app.activity base class, or possibly some other class that itself inherits from activity. You can have whatever data members you decide you need, though the initial code has none. Here we look at a onCreate method right here and right here. The onCreate method is invoked when the activity is started. We'll discuss the bundle parameter on onCreate in a later chapter. For the moment, consider it an opaque handle that all the activities receive upon creation. The first thing that you should do in onCreate is chain upward to the superclass so that the stock Android activity initialization can be done. The only other statement in our sub-projects on Create is to call the Set Content view. This is where we tell Android what the user interface is supposed to be for our activity. This raises the question, what does r.layout.main mean? Where did this R come from? To explain that, we need to start thinking about layout resources and how resources were referenced from within Java code. We will get to that momentarily. And of course, they're referring to these right here. And then in the real code, this right there. The OnCreate Options menu is used in Android to populate the action bar, or the options menu on older devices. We'll discuss the action bar in an upcoming chapter. For now, just ignore this method. Now let's get back to this mysterious R. Using XML Based Layouts. As noted earlier, Android uses a series of widgets and containers to describe your typical user interface. These all inherit from Android.view base class for things that can be rendered into a standard widget-based activity. While it is technically possible to create and attach widgets and containers to our activity purely through Java code, a more common approach is to use an XML-based layout file. Dynamic instantiation of widgets is reserved for more complicated scenarios, where the widgets are not known at compile time. For instance, populating a column of radio buttons based on the data retrieved off of the internet. With that in mind, it's time to break out the XML and learn how to lay out an Android activity contents that way. What is an XML-based layout? As the name suggests, an XML-based layout is a specification of widgets' relationship to each other and to containers encoded in XML format. Specifically, Android considers XML-based layouts to be resources, and as such, layout files are stored in the res layout directory inside your Android project, or, as we will see later, other layout resource sets such as like layout land for layouts to use when held in landscape. Each XML file contains a tree of elements specifying a layout of widgets and containers to make up one view. The attributes of the XML elements are properties describing how a widget should look or how a container should behave. For example, if a button element has an attribute value of Android text style equals bold, that means the text appearing on the face of the button should be rendered in boldface font style. For example, here is the res layout/main XML file that came with our sub project. And we can see it. Ooh, excuse me. Brain. And we're just going to go to the text. The class name of a widget or container, such as relative layout or text view, forms the name of an XML element. Since text view is an Android-supplied widget, we can just use the bare class name. If you create your own widgets as subclasses of Android.view, you would need to provide a full package declaration as well. com.commonsware.android.mywidget. The root element needs to declare the Android XML namespace. all other elements will be children of the root and will inherit that namespace declaration. The attributes are properties of a widget or container, describing what it should look and work like. For example, the Android layout center horizontal equals true attribute on the text view element indicates that the text view should be centered within the relative layout parent. We will get into details about these attributes, their possible values, and their uses in upcoming chapters. Note that those attributes in the tools namespace, for example, tools:context, are there solely to support the Android build tools. Eclipse in particular, and do not affect the runtime execution of your project. Android SDK ships with a tool, AAPT, which uses the layouts. This tool should be automatically invoked in your Android chain. Of particular importance to you as a developer is that AAPT apt from now on generates an r.java source file within your project's gen directory, allowing you to access layouts and widgets within those layouts directly from your Java code. In other words, this is where that magic R value used in set content view comes from. We will discuss it in a bit more later in this chapter. XML Layouts and Eclipse. I think I'm going to go ahead and skip a little tiny bit because we're not using Eclipse. Why use XML based layouts? Almost everything you do using XML layout files can be achieved through Java code. For example, you could use set text to have a button display a certain caption instead of using a property in an XML layout. Since XML layouts are yet another file for you to keep track of, we need good reasons for using such files. Perhaps the biggest reason to assist in the creation of tools for view definition, such as the aforementioned graphical layout editor in Eclipse, or Android Studio. Such GUI builders could, in principle, generate Java code instead of XML. The challenge is rereading the definition to support edits. That is far simpler if the data is structured in a structured format like XML than in a programming language. Moreover, keeping the generated bits separated out from handwritten code makes it less likely that someone's custom-crafted code source will get clobbered by accident when the generated bits get regenerated. XML forms a nice middle ground between something that is easy for tool writers to use and easy for programmers to work with by hand as needed. Also, XML as a GUI definition format is becoming more commonplace. Microsoft's XAML, Adobe's Flex, Google's GWT, Mozilla's Xzool, all take a similar approach to that of Android. Put layout details in an XML file and put programming smarts in source files. Many less well-known GUI frameworks such as ZK also use XML for view definition. While following the herd is not necessarily the best policy, it does have the advantage of helping ease the transition into Android from any other XML-centered view description language. Using layouts from Java. Given that you have painstakingly set up widgets and containers for your view into the XML layout file, named main XML, stored in res/layout, all you need is one statement in your activities on create callback to use that layout, as we saw in the project's activity. Here, r.layout.main tells Android to load in the layout resource R named at main.xml. And that's it for that chapter. We're going to go ahead and take a break. I'll see you all soon.